The asteroid belt isn't a static or eternal structure drifting quietly between Mars and Jupiter. It's alive, a vast, slowly decaying remnant of the solar system's chaotic beginnings. Over billions of years, it has been shaped and reshaped by countless collisions, gravitational tugs, and cosmic interactions. Today, scientists have uncovered something astonishing. The asteroid belt is disappearing. It's losing mass, fragment by fragment, dust grain by dust grain, fading slowly into the background of space. But this process isn't just a quiet cosmic event. It's deeply connected to Earth's past, our planet's violent youth, and even the impact risks that linger today. Stretching between the orbits of Mars and Jupiter, the asteroid belt contains billions of rocky bodies, from tiny particles no larger than grains of sand to dwarf planet-sized worlds like Ceres and Vesta. These large objects have mostly remained stable for billions of years, but they are the exception, not the rule. The majority of asteroids, especially the smaller and mid-sized ones, live in a constant state of turmoil. They collide, shatter, and grind each other into dust, fueling an endless cycle of destruction and renewal. It's within this restless population that the real story of the belt's slow disappearance unfolds. Astronomers, led by Julio Fernandez from Uruguay's Universidad de la República, set out to measure just how quickly the belt is fading. Using advanced models that combine orbital dynamics with collisional physics, they calculated the rate at which the asteroid belt loses its material. Their results were remarkable. The collisional region of the belt is losing about 0.0088% of its total mass every million years. It may sound like an insignificant number, but across billions of years, that loss adds up. The asteroid belt we see today is a mere fraction of what it once was. So where does this lost material go? The research shows that roughly 1/5 of it is expelled as larger fragments, asteroids and meteoroids that sometimes get nudged into new orbits, some crossing Earth's path. Many of these become meteors that streak across our skies, burning up in brilliant flashes. Others survive the journey and strike Earth's surface as meteorites. A few of them remain in orbit as near-Earth objects, silently orbiting our planet until gravity or chance draws them closer. The remaining 4/5 of the belt's lost mass doesn't survive in large chunks, it's ground down into fine dust, produced by billions of collisions over millions of years. That dust spreads throughout the solar system, forming the zodiacal light, a faint, glowing band that can be seen in the night sky along the ecliptic plane. The primary force driving this instability is Jupiter. Its immense gravity constantly disturbs the orbits of asteroids, creating powerful resonances that can fling smaller objects out of the belt entirely or send them spiraling inward toward the inner solar system. Saturn's and Mars' gravitational influences also play a role, but Jupiter's pull is the dominant sculptor, ensuring that the asteroid belt never settles into a permanent, stable configuration. Instead, it remains in perpetual motion, an evolving, decaying structure caught between the gravitational giants of our solar system. This gradual erosion has enormous implications for understanding our cosmic history. The asteroid belt isn't a preserved fossil of the early solar system, as many once thought. It's a living system, changing every moment. Over human timescales, the loss seems imperceptible, but over billions of years, the cumulative effect has thinned the belt dramatically. Astronomers estimate that around 3.5 billion years ago, the asteroid belt contained nearly 50% more mass than it does today, and its rate of depletion was roughly double what we observe now. That ancient, denser asteroid belt was a source of destruction across the inner solar system. The evidence is written on the surfaces of the Moon, Mercury, and Mars, worlds covered in scars from a time of intense bombardment. Earth, too, was part of that chaos. Vast impacts reshaped its crust, vaporized oceans, and even influenced the chemistry of its early atmosphere. Scientists now believe the asteroid belt served as the reservoir for that bombardment, feeding a steady stream of projectiles into the inner solar system. As it lost mass over time, those catastrophic impacts became less frequent, allowing the planet's surface to stabilize and life to eventually emerge. The connection between the belt's depletion and Earth's geological history is striking. As the belt thinned, the bombardment rate declined, a shift that aligns perfectly with the period when the first microbial life began to appear on our planet. In other words, the asteroid belt's slow decay may have played an indirect role in creating the conditions necessary for life to survive. Its instability gave way to balance. Chaos gave way to calm. The discovery also ties directly into larger models of planetary evolution, such as the NICE model, which suggests that Jupiter and Saturn once migrated inward and outward during the early stages of the solar system. This movement would have gravitationally destabilized the asteroid belt even more violently than it is today, ejecting massive amounts of debris and scattering asteroids across vast distances. The gradual depletion we observe now is the long, quiet echo of that ancient instability. It's a cosmic aftershock still rippling through time. Today, this slow erosion continues to affect our planet. Every fragment that escapes the belt has a chance, however small, of crossing Earth's path. Roughly 20% of the belt's lost mass becomes larger debris, contributing directly to the population of near-Earth asteroids. Although most pose no threat, some are large enough to be tracked and studied. Agencies like NASA's Planetary Defense Coordination Office rely on understanding this ongoing process to model future risks and prepare for potential impacts. Missions such as OSIRIS-RX, which visited asteroid Bennu, and DART, which tested asteroid deflection, operate within this broader framework, one that sees the asteroid belt not as a relic, but as an active source of new hazards. The remaining 80% of the belt's lost material turns to dust, feeding the zodiacal cloud that glows faintly around our solar system. Without this constant replenishment, the zodiacal light would fade completely within a few 100,000 years. Its persistent glow is direct proof that the asteroid belt remains active, eroding, grinding, and reshaping itself even now. By studying the brightness and spread of that light, astronomers can indirectly measure the rate at which the belt continues to wear down. This ongoing research offers more than just insight into our own solar system. It provides a framework for understanding planetary systems around other stars. Many young stellar systems observed by telescopes like JWST and ALMA contain debris belts similar to our asteroid belt. By comparing their brightness and composition to ours, scientists can estimate their ages, stability, and even the likelihood of having Earth-like planets. In this way, the slow disintegration of our asteroid belt becomes a cosmic reference point, a key for unlocking the evolution of planetary systems throughout the galaxy. Ultimately, the fading of the asteroid belt is a reminder that nothing in the cosmos is truly permanent. What seems fixed and unchanging is always in motion, always evolving. The same forces that shaped the early solar system, gravity, collisions, and time, continue to act today, quietly sculpting the future. For Earth, the asteroid belt tells a story that connects our violent past, our ongoing risks, and our uncertain future. It explains why our skies still host meteors, why our space agencies still track potential threats, and why understanding these processes is crucial for planetary defense. Far from being a static ring of rock, the asteroid belt is a living system, a decaying memory of creation. Its dust still drifts through the night, forming the faint glow of the zodiacal light. Its fragments still fall to Earth as silent messengers of a time when the solar system was young and wild. And its story, written across billions of years, reminds us that everything in space, even the most familiar, is slowly, inevitably changing. The asteroid belt is vanishing, but through its disappearance, it continues to shape the destiny of planets, the safety of worlds, and perhaps even the story of life itself.